Hi everyone, this is Babaiah, Assistant Professor of AC Department from MLR Hyderabad. Previous we learned the how to convert the block diagram into the signal flow graph. We need to follow the some of these steps. That steps are we learned for the previous session, but today we are going to solve some of the problems based on the conversion of block diagram into the signal flow graph. Now, coming to the first problem here, just observe. Determine the transfer function. Here, determine the transfer function. Transfer function is nothing but the output to the input, the ratio of output to the input. Here C by R for the block diagram given below. Here this one is converted into the signal flow graph. Finally we are going to calculate the transfer function by using the Mason's gain formula. That we are going to follow these steps here. First we need to follow the first convert the each and every take-off point into the node of the signal flow graph, and every gain can be represented on the between the two nodes. Like here, just observe. First, this is the R of S or else R is the input of the given block diagram, and C is our output of the given block diagram. Here, this is one of the summing point. This is the take-up point. Here also one take-up point is there. Here summing point is there, and here also one take-up point. Here this one is a summing point. Now we need to convert the every summing point is into the node and every take-up point into the node, right? And also input and output also we are going to represent it as a nodes. Here just observe. This R is the our input, just converted into the node, first node, and here just give the numbers also. Here first node, and second one is here take up point at the second node, and here third one is the summing point. Here this is the summing point, and here one more summing point is there, fourth one. This is the summing point. Next here take up point is there, just to mention the node, and here take up point is one more take up point is there, mention the node, and here summing point. This one is the summing point. After finally this is the output, so output node. All these are the, this one is the input node, and here this is the output node, this one is the input node, and this is summing or take up point and summing point. Here one more summing point, take up point, and here take up point. This one is the summing point and output node. These are converted into the nodes from the take-up point, summing point into the nodes we are represented here. Just here, next after that we mention the gain between the two nodes. Here see, input node is here R, and here the one more take-up point, this second point is this one and this one. Between the how much of gain is flowing here, signal is just only mentioned as 1 here. If they are not mentioned any gain of that given between the two nodes, we are going to assume the simply 1. Here this is the one gain, input node 2 and take up point, one signal is passing which has some gain is 1. And next here from node here take up point to summing point, we have a one more signal is passing from here to here, so that one is represented with the 1 also gain. And from D2 here, this one is the summing point from here to, just here observe, this one is represented here node, from here to gain is G1, and next summing point is here, from here to here. These two are the summing point, between the gain is G1. Next here from summing point, this summing point 1, 2, 3, fourth node. So fourth node to just the signal is here see observe, gain with gain is A and negative feedback here H1, so end with the minus, so minus H1. Here see observe, this one is the minus H1, just minus H1 enter into this node, and from here to gain is 1, here H1 end with the positive summing point, so directly we mention as H1 plus H1, here minus H1, right? Here gain is G2, between these two our gain is G2. From here to take a point this number to here, G3 is gain. From here to here, G3 is gain. Next here observe summing point. This is our summing point, number 1 2 3 4th. 1 2 3 4th, from fourth point here. Next this one is the fifth and sixth nodes. 5 6 5 6 number, 6 nodes. Gain is H2 end with the symbol is negative. Here observe, end with the symbol is negative, so minus H2. So minus H2 signal is enter into this summing point. Next here, the gain between the 6th and 7th nodes, just between the, there is not mentioned any gain here, directly mentioned as 1, we consider as the 1. After this summing point, from here to output node is directly we mention the gain 1. From here to just observe G4 gain from second node, G4 gain is passing to this last summing point. This is the last summing point. Just observe. This is the way of conversion of block diagram into the signal flow graph. Just first input node is converted the node. Next take up point is second one is one more node, and third is here summing point. This one is the node, and fourth is this one is node, and here fifth one is the take up point mentioned as node, and sixth one is the take up point here mentioned as node. Next here sixth one is node, and seventh one is the summing point. This is also node, and finally output is node. Total 8 nodes are here. Observe. Next we are going to follow the how many feedback paths are available, or how many loops are available here. See, first how many individual loops, we are going to follow the steps one by one. First, how many forward paths are available here. See, the signal is passing from the input to the output without crossing the more than 2 times of node, or more than 1 time. Here first node and second node, third node, signal is flowing like this. The arrow mark indicates the signal flow direction from input to and next node, and next one, and next here finally the output node. So input to output node, this is the one forward path. Next observe any more forward paths are available for the given signal flow graph. Just here observe, from here to signal like second node, and after that the gain G4, the signal is passing to the output node. This is the one more node. So one more second forward path. So how many forward paths total? 2 forward paths. Any possible of forward paths are available here. See, if the signal is passing like this is no, it is the opposite direction. This one is opposite direction, here also opposite direction. So here from the given block diagram, only possible of forward paths are only 2, right? So the 2 are the forward paths. The gain of the forward path, first forward path from 1 and 1, gain G1 into G2 into G3 into 1 into 1 is 1. So G1, G2, G3. Simply first forward path. This is the first forward path. How many forward paths total? 2 forward path. First forward path gain represented as the P1 equals to G1 into G2 into G3. This is the first forward path, input to output signal, right? Next second forward path is like this. Okay, second forward path P2, here 1 into G4, so 1, so G4 is the gain. So these two are the forward paths, gains and forward paths. Here k equals to, how many forward paths? 2. So k equals to 2. We are going to substitute that k value here. How many feedback loops are available? See, observe. This is from signal start here and here again ended the same node. When signal is started the node and pass some of the distance on the signal flow graph, after that again return back into the same node. So that is the loop, right? So here observe, this is the one loop, and from here to signal is passing like this. This is one. Next here signal is like this. So second. Next from signal starting here to here, this one. Third. So total three individual loops are available. Is there any individual loops are available? Once again observe here. For example, signal is passing like this. No, this is the opposite direction. So no. Here how many possible of individual loops are available here? Total 3 loops are available. First one, second and third. Total 3 individual loops are available for the given signal flow graph. Just here observe. First feedback loop. So here G2 and H1. So minus G2 H1. First feedback loop gain. Second feedback loop. So second one G1 G2 again here H1. So G1 G2 H1. Second feedback loop. Third one is here G2 and G2 G3 and H2. This is G2 H3. This is the gain of third feedback loop. First feedback loop is this one and second feedback loop is this one and third feedback loop is this one. The respected gains are mentioned here. So here next we need to calculate them. How many 2 non-touching, 3 non-touching, 4 non-touching loops are available for the given signal flow graph? Just here observe. Any 2 non-touching loops are available. For example, this is the first loop. This is the second loop. But these 2 loops are having the common node here. This node is common node for if these two comparison of 2 loops. So non-touching loop is not available. From here, just observe this one. These two are like this. The common node is here available. So common node is there. So there is no possible to identify the 2 non-touching loops. So 3 non-touching also not possible. So there is a no non-touching loops are available. So directly we mention the value delta equals to value 1 minus sum of individual loop gains plus 2 non-touching loops. 2 non-touching loops here. Delta we know already. Delta equals to 1 minus sum of individual loop gains plus 2 non-touching loop gains minus 3 non-touching loop gains, like that. Okay. So we know already sum of the individual loop gains. 1. 2 non-touching loops? No. There is a no 2 non-touching, 3 non-touching. So directly mentioned as 0. So delta equals to 1 minus individual loop gains. So delta equals to 1 minus first individual loop, second individual loop, third individual loop. So directly we mention all the gains in this place. Directly we get the value is P11 equals to minus G2 H1 and G1 G2 H1 and minus G2 G3 H1. All this just to substitute here. We will get the delta value. Next, we are going to calculate them. What is the how many forward paths? 2, right? So we need to calculate the delta 1 value and delta 2 value. So delta 1 is nothing but what? If the first forward path is not touching, if any loop is not touching with the first forward path, in that condition we are going to calculate the delta 1. If delta 2 we need to calculate, there is a any second for any loop is not touching with the second forward path. Here all the forward paths are going to be touch the first forward path. This is our first forward path, right? So first forward path, this loop is already touching, this one also touching, this one also touching. All 3 loops are going to be touch the first forward path. So there is a no non-touching loop for the first forward path. Directly 1 minus 0. So delta 1 equals to 1 simply. Delta 1 equals to 1, right? Next, delta 2 equals to, calculate the delta 2. Delta 2 equals to 1 minus of, here, non-touching loops. This is the second forward path, right? Second forward path. From here to here. Second forward path. So, second forward path. This one loop is first loop, second loop, third loop. All 3 loops are not touching the second forward path, right? Here, see. second forward path this one, but these three loops are not touching with this second forward path, so we have a non-touching loops are available. So directly write the 1 minus of first forward path, first loop, second loop, third loop. Directly we should write the delta value, directly we consider as delta we should write, or else 1 minus p1 1 plus p12 p21 plus p31, third one. Okay now, 1 1 2 1 3 1, all these, just we add all these three loop gains in this place. So that is the delta 2 equals to 1 minus of this value. So that is nothing but delta 2 equals to, directly we mention as delta. Okay, so delta equals to 1 minus this value. So we got the value delta 2 equals to 1 minus that, same we replaced by this completely value into the delta only. Okay, delta 2 equals to delta and delta 1 equals to 1. Now we have a Mason's gain formula. So just here for Mason's gain formula, summation, here I am writing summation k p k delta k divided by delta. So this is the transfer function. So transfer function k equals to 1. So delta k, delta 1 and delta 2. So p1 delta 1 plus p2 delta 2 divided by delta. Substitute the p1 value, delta 1 value, p2 value, delta 2 value. Directly we get the transfer function. This is our transfer function for the given signal flow graph or signal block diagram into the signal flow graph. This is our answer. Just here one more time, just observe here. Transfer function t equals to p1 delta 1 plus p2 delta 2 divided by delta. So finally this one is the p1 delta 1 plus p2 delta 2 value, and here directly value is delta 2 is directly delta 2 equals to delta. Substitute the value, delta value, and 1 plus delta equals to 1 minus of this value. So 1 minus into minus plus. So 1 plus g2 h1 minus g1 g2 h1 minus into minus plus. All this we are going to substitute in this equation. Finally we get the transfer function of the given block diagram by using the conversion method, by using the Mason's gain formula. This is the way of conversion of the given block diagram into the signal flow graph, and using the Mason's gain formula. For that we are going to calculate the transfer function for the given block diagram. This is the procedure to calculate the transfer function of conversion of the block diagram into the signal flow graph. I think understood everything. Coming to next problem, just this is the one problem, and one more problem just here observe. Input node is R here, output node is C here, mentioned as the node. Input signal is R and output signal mentioned as node. Here one more summing point, here also one more summing point, 1 2 3, and here summing point 4. This is the take up point 5. This is the take up point 6. This is the summing point 7. This is the take up point. This one also take up point. Finally output node 10. Total 10 nodes. Here observe. First node, second node, third, fourth, fifth. Here just observe. These two are just combined into here. Combined into the single node. First you should write here. First one is the input node, and second between these two gain is 1, and third node is here, between the gain is 1, and g1 gain between the third to fourth. Next fourth, from fourth to take up point and summing point, both two are combined into the single node. Okay now, and also here these three nodes are combined into the single node, here single node. Okay, so how many total? 1 2 3 and 4 5 6 and 7. 1 2 3 4 5 6 and 7. These are the 7 nodes here. Just observe the first node to Just observe this problem. Convert the block diagram into the signal flow graph and find the transfer function of the given block diagram by using the Mason's gain formula. First node, input and summing point. These two summing points are single. Okay, summing point. This one is summing point, and here next summing point, and next to take up summing point to summing point. Gain is G1. Next to take a point, summing point, both here combined. Okay. Next from here to G2 is gain. G2 gain. Next to take up point. Here the take up point. From this take up point to summing point and take up points. Here the next node. Gain between these two. G3. Next finally output node. 1 gain. Here the signal. See here first here. This node G2 gain node from this take up point, the signal is passing with the G4 gain G4 to enter into the last take up summing point. Here the summing point G4 enter into this. Next here one more here last, see observe, last one is unity feedback. So negative feedback with the unity, not mentioned any gain, so directly mentioned as 1, so end with the minus, so -1, so directly mentioned as here this one is the -1. Okay, next here observe from here to after the gain G2, the gain between these two, gain is feedback is H1, so feedback is H1, so from here to feedback is H1, so this is the enter into this second node, and here 1 2 3rd 4th one, 1 2 3rd 4th one, from 4th one to gain is H1, end with the positive, so positive gain, so this is the one feedback loop, so feedback loop. Next here one more here, this is the from here to feedback is third one, so here third 1 2 3 third one, both here combined signal 1 2 third, and here fourth one, both these two are the combining, right, these two are combining. From here the signal from H2 feedback signal H2 end with the positive only, so positive H2, so directly here move into like this. These are the loops, forward paths and feedback loops. Just here observe how many forward paths. First forward path, signal from here to passing like this. Is there any forward paths are available? Just to see the arrow mark, it indicates the signal flow direction. Here see observe, for example here no, opposite direction, so from here to opposite, from here to see one more, this is the one forward path. See here one more forward path signal like this, and from here to signal passing like this. This is the second forward path. So second forward path. Total how many forward paths are available? First forward path, then next second forward path, next here observe any more possible, here no, here no, here no, so two forward paths are available. So here also same, k equals to 2. We need to calculate the delta 1 value and delta 2 values also. Here first forward path gain P1, so G1 G2 G3, simple, this is first forward path. Second forward path like this passing, so here gain 1 1 and G1 and G4 and G1 and G4, second forward path. Okay, next loops. Next step is find out the how many individual loops are available for the given signal flow graph. Just to see observe from here to signal passing like this, and here again go back into the same node. So this is the one loop, G1 G2 G3 and -1, so minus G1 G2 G3 minus G1 G2 G3, this is the one loop. Next here observe one more, signal passing like this and this one. So G1, G2, H1, G1, G2, H1. This is the one more individual loop. Next here observe signal is passing here G2, G3 and no, this is the not possible. Just here observe one more G2, G3 and H2. G2, G3 and H2. Okay. Next feedback loop 3 completed. Next here observe if the signal is passing like this G4 like here from here to G1 and G4 and next here starting. So minus G1 G4. So minus like this. Same now. This is the minus G1 G4. One G1 and G4 and here minus feedback. So minus G1 G4. Next here observe last feedback loop. From signal starting here G4 again starting here G2 and same. So G4 and H2. G4 and H2. All these are the 5 feedback loops. How many possible of feedback individual loop gains are available total? 5 available. Here see observe all these are the 5 feedback loops are available. First one gain, second feedback loop gain, third and fourth, fifth feedback loop gains are available. Next we need to calculate the delta value. So any 2 non-touching, 3 non-touching loops are available. Just here observe. 2 non-touching for example. This one is these two combination of P11, P21. This is the one loop and this one is one more loop. But these two are combined the single node. So not possible in this condition. And also second for example like this one compare with this one and compare with this one also not possible. And compare with this one also not possible because of this one is same passing through like this common node also there, so not possible. So there is a no 2 non-touching loops are available. So directly we are not going to calculate the 2 non-touching, directly calculate the delta 1 and delta 2 and delta values only. So so here calculate the delta 1 and delta 2. For delta 1 means the first forward path. If the first forward path touches with any individual loops are available or not, we are going to observe. This is the first forward path. All the loops are going to be touched with the first forward path. So simply direct 1 minus of 0 only. Next, calculate the second one. Second forward path. This is the second forward path is P2 from here to signal passing like this. Like this one. So here see observe. This is the loop. So 2 non-touching and here also this loop is touching with the second forward. This one touching this one. All the loops are going to be touched with the second forward path. So here also 1 minus 0. So delta 1, delta 2 both are 1 only, right? So delta 1 value, delta 2 value both are the 1 only because of there is a non-touching loop is available for the respected forward paths. It means delta 1 or else delta 2, second forward path or first forward path. Here next we need to calculate the delta value. Delta equals to, we know already, delta equals to 1 minus sum of individual loop gains plus 2 non-touching individual loop, 2 non-touching loop gains. 2 non-touching, 3 non-touching, 4 non-touching like that. Okay. Now here 2 non-touching. Next 3 non-touching like this. There is a no 2 non-touching loops are available. So directly we mentioned as this one is 0. So delta equals to 1 minus individual loops are available. Total 5 individual loops are there. P11, P21, P31 and P41 and P51. All these values substitute here. 2 non-touching 0. So 1 minus all the individual loop gains. Here observe. 1 minus individual loop gains. Delta equals to 1 minus this value. Substitute the P11, P21, P31. we will get the delta value. This is the delta value. So directly substitute this value for the calculation of the transfer function by using the Mason's gain formula. So Mason's gain formula, we know the transfer function P of S equals to, or C of S by R of S is equals to summation K Pk and delta K by delta. So here K equals to 1. Substitute the P11 delta 1, P1 delta 1 plus P2 delta 2 divided by delta value. Just here substitute P1 delta 1 plus P2 delta 2 divided by delta. Substitute all the values in this equation. Finally, we get the transfer function of the given signal flow graph, or by using the block diagram into the signal flow graph conversion method. After that, we are going to apply the Mason's gain formula. Finally, we are going to calculate the transfer function. All these steps we need to follow for the every conversion of the block diagram into the signal flow graph, and finally calculate the transfer function. For that, we need to follow like this. These are the steps. First, we need to follow the how many forward paths are available. Before that, we are going to convert the every block diagram into the signal flow graph. Means every input node is mentioned as a here small circle, that is the node, and output also mentioned as a node, and also every summing point considered as a node, and every takeoff point considered as a node. And here the signal flow, the arrow mark indicates the signal flow direction on the block diagram. So we need to follow that signal flow, how where is a forward path is available, or else where is any individual loops are available, feedback loops are available. We are just to observe from the block diagram and convert them into the signal flow graph. Finally, we are going to calculate the how many forward paths are available, how many individual loops are available, how many 2 non-touching, 3 non-touching loops are available, or delta value also we need to calculate 1 minus of sum of the individual loops plus 2 non-touching loops, 3 non-touching, 4 non-touching, like that values. Finally, we are going to get the transfer function by apply all the gains in the given Mason's gain formula. Directly, this is the way of calculation of the conversion of block diagram into the signal flow graph, and calculate the transfer function of the given block diagram. Thank you, one and all.